Does life exist beyond Earth? The question of whether life exists beyond Earth is one of the most intriguing in science and philosophy. The quest to answer this ancient question leads us to one of Jupiter's moons, Europa. In this video, we'll reveal the mysteries of Europa and its potential to spot life. But before we delve into the mysteries of life beyond Earth on Europa, make sure to hit that subscribe button so you don't miss out on more fascinating stories, mind-blowing facts, and incredible discoveries coming your way. Europa is an icy world with a subsurface ocean beneath its thick ice crust. Scientists believe that if there are life forms beyond Earth, Europa's ocean might be one of the best places to find them within our solar system. That's why NASA is interested in Europa, one of Jupiter's moons, because of its potential to spot life. Decades ago, science fiction offered a hypothetical scenario. What if alien life were thriving in an ocean beneath the icy surface of Jupiter's moon Europa? The notion pulled Europa out of obscurity and into the limelight, where it has remained, stoking the imaginations of people both within and outside the science community who fantasize about humans discovering life beyond Earth. That fantasy, however, may be grounded in reality. In 1972, scientists using a telescope at Kitt Peak National Observatory in Tucson, Arizona, made spectroscopic observations that showed that Europa's surface composition is mostly water ice. Thermal models dating back in 1971 also suggested that the interior of Europa could contain a layer of liquid water. NASA's Pioneer 10 and 11 spacecraft flew by Jupiter in the early 1970s. But the first spacecraft to image the surface of Jupiter's moons in significant detail were the Voyager 1 and Voyager 2 spacecraft. If you want to know more about Voyager 1 and Voyager 2 mission, let me know in comment section. Voyager 1's closest approach to Jupiter occurred on March 4, 1979. The spacecraft snapped a full global image of Europa from a distance of about 1.2 million miles. A few months later, Voyager 2 had its closest encounter with Europa on July 9, 1979. Images from the two Voyagers revealed a surface brighter than that of Earth's moon, crisscrossed with numerous bands on ridges and with a surprising lack of large impact craters, tall cliffs, or mountains. In other words, Europa has a very smooth surface relative to the other icy moons. Even though the Voyager didn't pass extremely close to Europa, their images were of the high enough quality that researchers noted some of the dark bands had opposite sides that matched each other extremely well. These cracks had separated, and dark, icy material appeared to have flowed into the opened gaps, suggesting that the surface had been active at some time in past, led to a strong sense of anticipation for NASA's Galileo mission, which launched in 1989 and entered orbit around Jupiter in 1995. Galileo's primary mission included observations of each of the 4 Galilean moons during repeated flybys. The information about Europa that Galileo sent was intriguing that the mission was extended for 2 years follow-on journey known as the Galileo Europa mission. One of the most important discoveries made by Galileo showed how Jupiter's magnetic field was disrupted in the space around Europa. This measurement strongly implied that a special type of magnetic field is being created within Europa by the layer of some electrically conductive fluid beneath the surface. Based on the Europa's icy composition, scientists think that the most likely material to create this magnetic signature is a global ocean of salty water. In 2024, NASA launched a Europa Clipper mission, which will study the icy ocean of the Europa and try to find out the life on Europa. Life as we know it seems to have 3 main requirements: liquid water, certain chemicals, and an energy source. Also, life takes time to develop. Europa's ocean may have existed for the entirety of our solar system's history, approximately 4 billion years, so sufficient time has passed for life to develop. Astrobiologists, scientists who study the origin, evolution, and future of the life in the universe, believe Europa has abundant water and the right chemical elements, the building blocks of life, including carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. The third ingredient for life is energy. All life forms need energy to survive. On Earth, most of that energy comes from the sun. For example, plants grow and thrive through photosynthesis, a process that converts sunlight into energy. The energy is transferred to humans, animals, and other organisms when the plants are eaten. But the type of life that might inhabit Europa likely would be powered purely by chemical reactions instead of by photosynthesis, because any life at Europa would exist beneath the ice where there is no sunlight. Europa's surface is blasted by radiation from Jupiter. That's a bad thing for life on the surface. It couldn't survive, but the radiation may create fuel for life in an ocean below the surface. If we eventually find some forms of life at Europa, it may look like microbes or maybe something more complex. It can be demonstrated that life formed independently in two places around the same star. It would then be reasonable to suggest that life springs up in the universe fairly easily once the necessary ingredients are present, and that life might be found throughout our galaxy and the universe. If you love exploring the mysteries of the universe and want to join me this journey to uncover the wonders of life, make sure to hit that subscribe button. Don't miss out on more fascinating stories, mind-blowing facts, and incredible discoveries coming your way. Together, we'll unreveal the secrets of our universe. So subscribe now and let's embark on this adventure into the unknown.